All right, hey everyone. So here is an example of dealing with something launched at an angle that is not from the floor. So an object launched with a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal from a height of 3 meters. How far away does it land? So first thing we want to do is just go ahead and draw a picture here. So we have a height of 3 meters. We have this thing being launched at an angle of 25 degrees relative to this horizontal here. We know the ball is going to go up and it's going to hit the ground some distance away, and that's the distance we want to find. So how far away does it land? So we're trying to find this delta x here. Now, before I go into solving the problem, I just want to go ahead and break this down. So if I create a triangle, I know I have my initial velocity, which is 20 here, and that forms an angle of 25 degrees. So this here is my initial x component, and this here is my initial y component. Since x is the adjacent side of the triangle, that tells me that the initial x is going to have to be 20 cosine of 25. So adjacent equals the hypotenuse 20 times the cosine of the angle. The initial y is at opposite side, so it's going to have to be the hypotenuse times the sine of 25. So let's go ahead and make a list of what we're given. So I'm given the initial x velocity and the initial y velocity, which we have written out up here. I know the height is 3 meters, so that makes delta y actually a negative 3 meters, because it actually has to fall 3 meters from here to here, or from here to the floor. So delta y is going to be negative 3. I know that for any projectile, the acceleration in the y direction is negative 9.81. And what am I trying to find? So I need to find delta x, but I know in order to find delta x, as in most projectile motion problems, I also have to find t. So the only thing I'm missing here is v final y. So because I want to find how far away does it land, that's the x direction, I actually want to start in the y direction to find time. So I have to choose a y direction equation that does not have final velocity. The only one that meets that is this equation here. So I go ahead and plug in some numbers. Negative 3 v initial y, so that's 20 sine of 25 plus 1/2 negative 9.81 t squared. Now let's go ahead and simplify this, as I can see that I'm going to have a quadratic in terms of time. So I have t and t squared, quadratic equation. Quadratic has to be equal to 0, so I need to move that 3 over to this side, and then I'm going to simplify these into decimal form to make it easier to work with. So I'd have 0 equals 3 plus 20 sine of 25 is 8.45 t. 1/2 times negative 9.81 is negative 4.905 t squared. So now I got to plug this into my calculator or quadratic equation solver. So this here's my a term, my b term, and my c term. Quadratic equation spits out 2 answers. That means I'm going to get one answer. One of the answers is 2.02 for time, and the other is negative 0.3. Obviously, time can't be negative, so it can't be this one, and it must be this answer here. So now that I have my time, I can take that, plug it back into my x direction. So I have delta x equals the initial velocity in the x direction All right, so that was weird. Oh, we have that delta x here equals v initial x t, or 25, or 20 cosine 25 times that 2.02, or 36.6 meters.